Okay, so in this video I'm going to show you one of the examples of clustering. So I'm going to be using the K-center clustering algorithm. So first of all, let's make this full screen. Okay, so now it's full screen. I've also loaded my code and slides and whatever. So let's go to the first slide. So I think now we are on the first slide. So yeah, now it's the first slide. Let's clear everything. Right, fresh page. The first slide contains this code, which is just me initiating some variables. So I'm just creating this big data dictionary. No, I shouldn't say dictionary, it's not Python anymore, but yeah. So I'm creating this data object which contains our x and y coordinates for our data points, and our data is just two-dimensional, so I can just make a scatter plot, and the clusters will be displayed using the color. So here I have 10 colors, and yeah, let's first of all run this slide. So nothing happens because I'm just initiating some variables. Let's go to the next slide. So over here you already have a graph because that was made in the when I used this previously. So this is the code on this slide. So here I'm actually like plotting some stuff. Okay, so let's run it. So this is the first thing. So like this becomes red completely, and you can see there's this black dot. This is our center, so I've chosen this center randomly. Okay, and of course all of these points belong to the same cluster. I mean, all of these points are red and they are belonging to the same cluster, which is labeled 0. And you can also see the label for the cluster to which, I mean, okay, the label of the cluster which has the biggest radius, that's what I should say, that's 0, and the next cluster will be 63, that's what this second number is, and this is the current radius or the current cost of our clustering. Okay, so let's cluster once again, that is add another center. So I add another center. This center is added at the point which is farthest away from this point. So that was the point 63. So the 63 third index in our data array, which is this point, and now all of these points belong to the first cluster. So the red points 0th cluster. This first cluster, I'm using programming notation for indexing, but don't get confused. Basically just successive clusters, that's what it means. So yeah, now all of these belong to this cluster, and this is the center for that cluster. Let's run that again. So now you have a third cluster, right? So the way I have implemented clustering over here is that I go over the whole data list, right? And for every element, so every point, you could say, so like these points, right? So for example, this is a point over here, right? So for this point, I'll like see that, okay, what are its distances from this, and from this. I'm not drawing on my phone using the stylus, so this is a bit weird, but yeah, you'll just see what these distances are, and you'll figure out, okay, what is the minimum distance, and this is the minimum distance, right? So that will be the center of the cluster that our point will belong to, right? Yeah, and this is gonna happen with the hidden clusters as well. So there's this cluster 125, which we'll be using in the next the next time we run this code, but right now for 3 clusters, this point belongs to this centers cluster, right? And so now it's red. Similarly, for every point, you have to choose which cluster should it belong to, which is of course chosen by taking the minimum of all the distances from centers, right? And once you do all of that, now you have these pairs of points like this and the centers, right? So now the task is figure out which pair has the biggest distance. So for example, when I ran this the second time, this distance, so from here to here, was the biggest. So that means that the pair of this point and this point, well, that was the pair that was giving us the biggest distance, and this was already a cluster. So it's like this was already a cluster, so all we had to do was put this as the next cluster, so that this biggest distance thing is, or I should say the cost of the clustering, so the cost of the clustering is minimized, right? and then the new cost will be something smaller, and you keep going like that. Eventually your cost decreases. Okay, so let me run this again, and there are actually going to be 10 clusters because that's the number of colors I've chosen. If I go more than 10, then it will do some very weird thing, but let's just go at it once. So another cluster, this yellow one, keep going. Right, so right now we have 1 2 3 4 5 6 7 8 9 clusters. This is the 10th cluster, and if I run it again, there's some weird thing happening because the 11th color is not defined. So yeah, the browser just thinks, oh well, the 11th color is not defined, let's just choose any color that you want. So it does some weird thing. But yeah, that's the way clustering works. Right, actually, undo that. Right. Oh, okay, so it actually completely cleared it because I was running this, so that's why. Fine. But yeah, okay, so now it's doing it even more, so that this is like, oof, this is really bad. Anyway, the point is, that's how k-center clustering works, right? And this code I've written is actually a very bad implementation of this thing, because the problem with this code is I'm iterating over the whole data array, and I'm re-evaluating the distances that I already know. The distances to all the previous clusters for a certain point, I already know those, so I shouldn't have to evaluate those again and again. But then again, this is a software I made, so I was just like, excited to try it out and make something good with it, and this is what I came up with, just k-center clustering. I'm not going to do k-means clustering on this software. It's not meant for stuff like this. Actually it is, but not exactly this stuff. It's like more for 3D animation and all that. Anyway, yeah, that's it. I'll see you guys next video. How do I close this? Oh yeah, escape. Okay, so I'll see you guys next video.